In an earlier lecture, we spoke about impulse, and we said that impulse is the change in momentum of an object when a collision takes place. So, an object experiences an impulse when a collision takes place between that object and another object. So in this example, the wall is one object, and this wall with a mass of 0.05 kilograms is the second object. So the wall is stationary, and the object initially, before a collision, is traveling with a velocity, initial velocity of 30 meters per second, and an angle of 45 degrees with respect to the x-axis, so above the x-axis. Now, after our collision takes place, after the object experiences the impulse, it travels in the following direction at an angle of 45 degrees below the x-axis and has a magnitude, the velocity has a magnitude of 30 meters per second. So our velocity before and after collision has the same magnitude, but it differs in direction. And we want to calculate the impulse of the collision using this information. So, in order to calculate the impulse of our collision, we have to calculate the change in momentum. And to calculate the change in momentum, we have to calculate the change in velocity, because momentum is equal to mass times velocity. So notice that before the collision takes place, we have our vector, velocity vector, which has an x component and a y component. Likewise, after our collision takes place, we have the following velocity vector that also has an x component and a y component. So, in the first step, we have to calculate the x and y component vectors before the collision. In the second step, we calculate the components after the collision. Then we use that information to calculate the change in velocity, and finally we use the change in velocity to calculate our impulse or change in momentum. So we begin by looking at the following triangle. So we have a 45, 90 degree triangle where the base represents the magnitude of the x component and the height represents the magnitude of the y component before the collision takes place. So the x component is sine 45, which is square root of 2 divided by 2 times 30. So we get a result of 15 radical 2 meters per second. The same exact step should be done for the y component, except now we have cosine 45, which is also radical 2 divided by 2. So radical 2 divided by 2 times 30 meters per second gives us 15 times radical 2 meters per second. So notice we have the same exact magnitude for the x and y component vectors for the velocity before collision. Now after collision, the same exact steps are taken, except now we have the following 45, 90 degree triangle. So we have our final x component vector is cosine 45 times 30. So likewise, it has a magnitude of 15 times radical 2 meters per second. And the y component vector for after our collision takes place is sine 45 times 30. So once again, 15 times radical 2 meters per second. Now notice our magnitudes are identical, but notice for the x component vector before and after collision, our directions are opposite. So that means if we choose this to be negative, this must be positive. So we choose going this way to be positive and going this way along the x-axis to be negative. And notice our two y component vectors point in the same direction. So we choose going downward to be positive, going upward to be negative. So, now we go to step 3. We want to calculate the change in velocity along the x-axis and then calculate the change in velocity along the y-axis. So once again, along the x-axis, we have final velocity minus initial velocity. Final velocity is 15 times radical 2 minus initial velocity is negative 15 times radical 2. The negatives become a positive, and so we have 30 times radical 2 meters per second. Now notice we have a slightly different situation taking place along the y-axis. The change in velocity along the y-axis is 15 radical 2 minus 15 radical 2 because they point in the same direction. So they're both positive. And we get a change in velocity along the y-axis to be 0 meters per second. So now if we want to find the change in velocity, we simply have to take the square root of the sums of the squares of these values. So square of this plus square of this simply gives us 30 times radical 2 meters per second. And now to find the impulse given by an uppercase J, that equals change in our momentum, which is equal to the mass of the object, 0.05 kilograms, times the change in our velocity, which we just found to be 30 times radical 2 meters per second, and we get 1.5 times radical 2 kilograms times meter per second. So this is our impulse or change in momentum of the object when it collides with the stationary wall.